We're going to collaborate with the precast bridge industry in developing innovative experiences, including seminars, courses, and competitions in the area of precast concrete bridges for civil engineering and construction management students. It's the first bridge-focused studio program in the country.
Working with industry professionals throughout, as well as working with the construction managers on one project, it was just a phenomenal experience that provides both the experience, the immersion into it, and it really prepares us for the future.
I first heard about it my last semester when I was in a structural laboratory course from my professor, Dr. Matsumoto. He mentioned about this new class that's coming up. We're working with CM students, and it really seemed like an interesting opportunity.
In this class, we learned how to work with real-world people, and the benefits of that is you have a diverse set of questions. You have a new set of questions where they're asking you about real-world problems, not a theoretical problem that we may have discussed in a classroom from a book. These are real issues in the real world.
As a construction management student coming into this class, it was very important for us to collaborate together with the civil engineering students and work towards the common goal.
Let me take another couple minutes and make it super clear what the objectives of PBS are. Number one, educate. Notice under red, civil and CM students. This has never been done in the history of the college until this class. CE and CM students, unfortunately, don't talk that much and haven't coordinated in a class or in a project, and we're very excited that was our first objective. This is one of my favorite pictures of the semester. Yes, that's a CE and a CM student. That was the first ever meeting between CE and CM students in the history of our college. So,
can you guess which is which here?
Yeah, you got to guess who's who. Jim Voss, one of the movers and shakers related to the PCI Foundation, said, "We realize that not every bridge and not every structure is going to be precast, but we got to give precast a seat at the table."
This class prepares students in a very distinct way, in a real-world way. As Professor Matsumoto noted, it's more than just girder design, it's actually bridge design, at least the superstructure component. As an example, I'm fortunate to have one of you students join me at my firm starting next week. And point I'm making is that he's going to be starting right away on a large project with several hundred girders of various sizes, length, depths, and so on. And you know, stepping back, why would I put a new student on such a project? Well, because this class has prepared him for it, and I've got confidence that he's going to start off very quickly. It's a new twist, right? Adding CM students to the interaction, and again, that kind of mirrors what we really do in the industry. You want that connection with the CM during design. The projects selected for each team are real projects provided by us mentors. The student groups were given just the basics, just a general plan, site conditions, so on, the rural constraints, whether they're crossing a freeway, a creek, a railroad, just the basics. So out of that, we have 4 different types of girders. I hope I got these right: voided slab, wide flange, box girder, and an eye girder.
Good afternoon, everyone. We are the Concreteers, and it's a pleasure for us to present before you this afternoon. We'd like to start off by acknowledging our team mentors, both Jeremy and Rob from Dock and Engineering, as well as Professor Matsumoto, who made this possible, and Professor Michael Anderson as well. We'd like to speak to you about the Wheatland Gate Bridge Replacement Project.
This generated a 6-week construction window that is one of the biggest risks on this project. And by utilizing the design build delivery method and selecting the precast girders, we were able to deliver in that 6-week construction window.
So for our live load design vehicles, per AASHTO, we're supposed to design it to HL 93 at service 1, service 3, and strength 1. For Caltrans amendments, we had to design using the P15 load. And this is a fictional truck that has an enormous amount of weight, which is represented in these figures above.
So our design progression began with finding the number of required pre-stressing strands, and that consisted of service 3 load combinations at the critical location, which is tension at midspan. So our initial design consisted of 32 strands and 4 temporary strands at the top. However, when we did check our stress checks at transfer, we found that it would basically fail at the casting yard. And this is due to the camber that occurs, and the top is in tension, and you see the location circled in red. At that point, there's not enough dead load to counteract the tension at the top, and so you would expect cracking to happen at that point. So we had to consider either harping or debonding the strands.
So now that we talked about how we're going to design it and build it on paper, we're going to talk about how we're actually going to build this in the real world. So as construction managers, we have a lot of risk involved when we're doing this type of work, given there's a crane. We're erecting these very heavy girders, so there's a lot of pre-planning involved, but being able to work on a design build with the design team, we were actually able to work out a lot of the issues that we found in the pre-construction phase and get those addressed prior to construction. Because we do have a very accelerated schedule, so using the design build method and a precast girder really helped us accelerate that schedule.
On the screen, you also see a pour plan or site logistics. This helps us plan our project well and also demonstrate to everyone and to you guys how we plan on building this project. All the different colors represent the different pours that we have in our substructure, because without the substructure, we could not erect our girders.
There was definitely a lot of lessons learned throughout this entire project, and with working with the CM side, the one that stood out was definitely the difference between designing on paper versus fabricating and construction.
Our CMs also learned that the CAs aren't that bad.
CMs aren't that bad either.
Going to docking and learning from Rob and his great diagrams he draws, and going to confab and seeing the concrete actually get produced, and wrapping it all up with seeing the bridge the girders actually being erected. That was probably the biggest highlight for us. And with all this great stuff, it was a big cost. There's a cost of time. There's cost of our sleepless nights, that guy over there, our headaches and anxiety, and the countless emails from Matsumoto at like 3 in the morning. But we also learned that we got the value of working as a team was absolutely priceless.
So if the new bridge lasted another 70 years, would that be considered a success?
Yeah, you really can't put a price on safety of the public.
Right. Okay.
Great job. Thank you all very much.
As was mentioned before, we've had the privilege of working with some very talented, very skilled, very experienced engineers who have taken a lot of time out of a very busy schedule to work with us, and we appreciate that immensely. We could not have done this without the help of Mr. Fish and Mr. Phillips, who were there even on days when their boss probably wanted them at work, helping walk us through projects. Mr. Phillips, I want to thank you especially for sitting and walking me through a number of design aspects that I just would not have been able to address or think of on my own. And so I would like to present this to you on behalf of the A-team.
Well, I don't think I've ever been called brilliant before, so I'll take that. But our students are really smart. They had us, they asked a lot of questions that, you can tell how much someone's understanding and how much they're trying to understand by the questions they ask. And the whole team asked really good questions that kind of put me back on my heels, so it really speaks to their understanding, their want to understand bridge design and take this as a serious profession and bring a lot to the industry. So everyone on my team, I look forward to working with you in the industry in the future years, and it's a really great opportunity. I came to this thing last semester and was really inspired by all the hard work that Eric had put in and the students had put in and the mentors, and it's really a great program, and I hope to be a part of it for semesters and semesters to come. So.